Okay. Okay, so today I will give a lecture on the geophysics. Yeah. So as I mentioned in the previous lecture, geophysics is the also the subsurface investigation. Yeah. So if you normally, yeah, if you have a project, yeah, then you need to do site investigation. Yeah. So if you cannot have so many borehole, yes, project, of course they have a we have a budget constraint, and so we cannot have allocate so much money for borehole, because borehole is expensive. Yeah. So you can cover the area which is don't have borehole with a geophysics, yeah, so that you can know the surface soil profile, yeah, of your construction area, yeah. Okay, and then beside that, you also can get the water flow, yeah, using geophysics, yeah, so that because you cannot, we can, when we design or develop the area, can we have to know where is the water path, yeah. Don't locate your structure on the water path lah, yeah, because if you close, yeah, the water, mean that you cover the water path, yeah, to make a platform, then you construct a structure on it, yeah. So after some time, the water, of course, water will find a way to flow lah, yeah. And if the water flow under your structure, then your soil, yeah, will become the strength of the soil will be weakened because of the water flow, yeah. So that's why, yeah, now if you construct nowadays, yeah, the engineer normally they will ask the contractor to do geophysics lah, so that they can know the water path, yeah. Because if you don't consider the water path, yeah, normally if you construct the structure on the slope area, yeah, at the slope area, yeah, after some time the slope will fail lah, yeah. So that's what happened in Bukit Antarabangsa, yeah. So they construct the structure Bukit Antarabangsa nearby Ampang, Ampang, Kota Damansara, Bukit Antarabangsa, if you know the area, yeah. In Kuala Lumpur, there's a lot of landslide occurred at the residential area over there. This is because of the water path. They construct the bungalow lots, yeah. At that time they construct the water path, the structure on the water path lah. They cover the channel, yeah, to make a platform. Then after some time the slope fail because of the water lah, yeah. Okay, so that's why the seismic the geophysics test is important, yeah, especially if you design structure on slope, yeah. Okay, and then normally if you design for the slope structure, yeah, at the sloping area, so it's difficult for you to bring equipment, yeah, for borehole, yeah, because I show you the photo of the equipment, kan, it's very big, so they have a pump, and they need to have a water supply also to do the borehole lah, yeah, the SPT test. So if you have that constraint on your area, in your construction area, so you can replace the replace with geophysics lah. Yeah. So with geophysics, yeah, you still can get the soil profile. Yeah. So you don't have to do so much borehole. So you can do the borehole at top of your slope and bottom lah. Yeah. So in between, so you can do geophysics. Yeah. So with that, so you can get the soil structure along the way lah. Yeah. So that is how it works. Yeah. So okay, let's go to, so that is the introduction lah. Yeah. So let's go to the slide. Yeah. So this slide I uploaded in Google Classroom last night. So I hope you can have you can have a look lah. Yeah. Okay. So can you see the slide then?
Yes, madam.
Can you hear my voice?
Yes,
Because
madam.
I not
Yes.
talk too loud. Okay, if you have any question, yeah, just turn on your mic and ask lah. Yeah. Okay, if cannot, if I talk too fast or you can't hear my voice, let me know, right? Okay. Geophysics survey, yeah. Okay. So for the soil investigation, in soil investigation we have geophysical survey, yeah. All right. So there are two tests on geophysics. Yeah. First one is the seismic test, and second one is the resistivity. Yeah. So for seismic test, yeah, we can know the soil profile. Okay. So we can know the layer of soil. Okay. And geophysics is for to know the water content lah, yeah, underground. All right. So that is the difference between the two. Okay. Okay, now we move to seismic refraction survey. Yeah, for the seismic test. Okay, for the introduction. Yeah, seismic wave are the wave of energy that through the earth. Yeah, for example, as a result of an earthquake, explosion, or some other process that impact a ground. Yeah, impacted ground, right? So that is the seismic waves. I think all of you know what is a seismic test, and because of the wave that result earthquake. Yeah, yeah. Okay. That is the seismic wave. Yeah. Okay. Wave are travel into the ground. Yeah. So the wave will travel into the ground. So this is the ground surface. Ground layer, ground surface reflect to the ground surface, yeah, and then refracted back, yeah, to the surface. Okay, so that is the seismic wave lah, yeah. All right. Okay, adaptation usage of seismic, yeah. So there's a few usage, yeah, and of seismic. So one of them is we will concentrate on this one, yeah, geotechnical engineering purpose, yeah. So that has some other purpose, yeah, for environment, geological and engineering research, groundwater exploration, yeah, exploration mineral, yeah, exploration of archaeology artifact, yeah. So for the archaeology artifact, they also can use the seismic to trace the artifact, yeah. Okay. So three types of seismic waves that travel into ground, yeah. First one is look at the photo here, yeah. So first one is the direct wave lah. Alright. So when you knock the hammer, yeah. Yeah. So that travel into the ground, yeah, there are three. Yeah. First one is the direct wave. Okay. And then second is the reflected wave lah. Yeah. So the wave reflected from the surface discontinue of junction of two different media. Yeah. And the wave that travel back to the source end of the mismatched transmission line. Yeah. So normally when you knock, yeah, so you do the test when the wave reach the to the different layer, yeah, it will reflected back lah, reflected back. Yeah, they must be there. Yeah, only then they can reflected back lah. Alright, refraction wave. Yeah, so this is the refraction wave lah. The wave move out from the soil surface, from the soil surface. Yeah, that is the refracted wave lah. Yeah, wave likely is change direction bend by moving from the one material to other material of the different density lah. Yeah, so when you knock, yeah, so first one they have refracted wave lah. Okay, when it reach different density or different layer, yeah, then it will reflected back to the surface lah. Yeah, so that is how the wave works. Yeah, in seismic refraction study, yeah, refraction wave are used for interpretation. Yeah, so in a seismic study, they will interpret this one refracted wave, right? Meaning that the wave come out from the surface lah, right? Seismic refraction provide clear differentiation of rock and soil boundary. Yeah, so I will show you the result of the seismic test, so you will know the layer. Yeah, so you will know the boundary between the soil and the rock, right? So because you can get the soil layer in, so you will know the boundary lah. Cannot use dot pen. Wave that generate into ground. Yeah. So there's a two wave lah generate into ground. Yeah. First is the active wave. Yeah. And second one is the passive wave. So the active wave that generated by source. Yeah. Slash hammer explosion. So when you do the test, yeah, normally we will for the seismic, and also same goes resistivity test. Normally they will use slash hammer lah. Yeah, I will show you the photos now. Yeah, it's very heavy this one. Yeah, slash hammer, or sometimes they will use explosion lah. Yeah, to give to generate the wave. All right, and then second one we have passive wave lah. Yeah, wave that generated from surrounding environment. So the movement of the car, yeah, the movement of the people, yeah, running, yeah. So that is the passive wave lah. All right. So that is the difference between the two, yeah, active and passive wave, right? Seismic study consists of survey, yeah, survey to determine and mark location of source and receiver. Yeah, so you need to have a survey, yeah, to mark the location of the source and receiver. Yeah, yeah, and the source, yeah, generate to release or produce energy. Yeah, so source is the hammer or explosion using dynamite. All right, and then geophone detect the seismic wave. All right, and then seismograph. record and measure a motion of the ground, including seismic wave. So I will show you the photo just now. What is the source, geophone, and seismic graph lah. All right, and also the survey. Okay, so survey is like a normal survey lah, that you have learned in year 1 with Dr. Buhari. Now is Dr. Buhari lah. Previously is Mr. Amin So first one, to do the survey test, seismic test, you need to have a survey lah. Okay, normally before they do SI, because before we proceed with SI, normally we need to do the survey first. So that from the survey you will know about the location lah. So what is the thing that that we have on site, so we can get from the survey plan. So I hope you're familiar with the survey plan. I think you already taught the apa class, IDP class, right? You already know what is the survey plan kan? I hope you're familiar with the survey plan already. How to read the survey plan. For the source, geophone, and seismic graph, I will show you later on in the next slide. Right? Seismic refraction survey method usually used in geotechnical purpose. A seismic line consists of series of 24 geophones with 12 on either side of the geophone center. Okay, so this one. So for the test, we have 24 numbers of geophone. So normally we will put the seismograph ni here, seismograph here. Okay, and then they need to arrange the geophone 12 side by side lah. So in total is 24. All right. Okay, the geophone are laid down about 5 meter length to each other under subsurface. Okay, so normally this one, they will arrange 5 meter lah, center to center, the geophone. Okay, shot will be performed about 7 times, using sledgehammer, which divided into fast shot, for 2 times, and shot 2 times, intermediate shot of for 2 times, and the middle shot. So here the photo here, so fast shot 2 times, 2 times, 2 times, and this one 1 time. So they will knock the hammer here lah. Far shot ni 2 times, and short and intermediate shot also 2 times, to generate the wave. Alright. Okay. Each geophone will receive signal, seismic wave that produced by sledgehammer, the shot lah. Meaning you knock the hammer on the ground, and it's recorded in seismograph. So the seismograph ni, it will record all the wave lah. Alright. Okay, ni. So that is how they do it lah. Principle of seismic survey. So this is the hammer, and then the geophone, and then seismic lah. So to knock using the sledgehammer. Okay, so they knock, right? Okay, and then sound path. Okay, so the wave moving, reflect, and then refracted back. Okay, to the geophone, and then the lastly record by the seismograph lah. Alright. Okay. So this is the raw data. Yeah. And I hope you can imagine how they conduct the seismic test lah. Yeah. So the example of raw data. Alright. So the seismograph, seismometer, will receive the wave, the raw data like this, and then they need to interpret this data, into this. Alright. Example of interpreted data. Yeah. So from this raw data, they have to interpret the data into this one. Yeah, will do lah. Yeah. So like Dr. Bukhari, you know Dr. Bukhari, right? He also the geotechnical engineer, so his PhD is doing this one. Yeah, so he can he interpret this one, into this one. Yeah. Okay. If you want to learn more, so you can ask him lah. Yeah, but in our university we don't have the geophone and the equipment yet. Yeah, because one geophone costs you like 10,000 ringgit, so it's very expensive. So we don't have the budget to buy the equipment yet. Yeah. Okay. All right. Okay. So as I mentioned just now, if you have a slope project, so you want to construct the retaining wall, by example, so you need to know the layer of your soil, right? So normally you cannot have the you can, but it's difficult. Yeah. Okay. So because you need to bring all the equipment on the slope here, so it's difficult and it will cost you a lot. Yeah. So that's why normally for the slope project, if you want to design a retaining wall, by example, so normally we go and have one with the bottom of the slope and one more at the top of the slope. Yeah. So in between, if you want to know the soil layer, so you can do the seismic test. Yeah. So by example here, it's quite small. Sorry, this one is the apa tu? Survey lah, survey plan. But this one is a survey plan, and then you as an engineer have to mark the location, the line, for your seismic survey. All right. Okay, and then you pass this one to the contractor, to do the seismic survey lah. Yeah, so they will arrange the what is it called this now? Geophone, on the slope. All right, because the geophone can is easy to mobilize, right? So they will arrange the the geophone here, and then they will do the test lah, right? So so you can get the soil layer. So here, you can see the legend here. So the legend at the top here is the soil layer. The brown color is the soil layer, and then at the bottom here, so you have rock. So when you design for your wall, Yeah, for example, you design for your wall. Yeah, you can, if you encounter they have a rock layer, so you can choose apa tu, bore pile lah as your foundation. Yeah, and normally for the slope failure kan, they will occur at the soil layer, so you can roughly know the shape of your slip surface lah. So if you have this one, yeah, seismic test. Okay. So the maximum apa tu depth, yeah, the maximum depth ni, the maximum depth of your slip surface. So you cannot, for the slope kan, when you want to install the apa tu soil nail, for example, you have to make sure, yeah, the length of your soil nail, yeah, is beyond the slip surface. So if you use this one, you can roughly know lah the slip surface. Ni silap lukis ni. Yeah. So normally is before the rock layer. Yeah. So you can roughly the length of your apa tu the length of your soil nail. Yeah. Okay. That is one of the advantage lah of doing this one. Okay. Okay, so this is the area, yeah. So we can see a lot of seepage, yeah, seepage, yeah, and then the height of the slope, yeah. There's a slope failure here, yeah. So you can see the scarf here, yeah. So the this is the photo of this area lah, alright. Okay. Okay, so this is the photo of the seismic survey performed at site. Yeah. So this is, they will arrange the geophone, yeah, 5-meter interval lah. Yeah, for each 5 meter they will put, every 5 meter they will put one geophone. Alright. And then this is this one, yeah. It's a slash hammer. Alright. And then this is the seismometer. Yeah. So someone have to read this one. Okay. Someone need to knock the. Okay. And then there's a wire lah. Yeah. To connect from the geophone to the seismometer. Yeah. Ada tak video ni? Oh, tak ada. Okay. Jadi kembali semula. Sekejap. Okay, so right, what kind of equipment used in a seismic survey? Yeah, so this is the photo of the geophone. Alright, and then this one is the here is a seismograph lah, the reading. Yeah, this one is called seismometer. Right, and then this is the slash hammer. Alright. Table seismic conventional wave velocities, right? Okay, so so this is the material, okay, and then this is the wave lah, the reading of the wave, but is differentiate, yeah, is differentiation between unsaturated and water saturated soil. Okay, so if the water is saturated, yeah, so the reading is referred to here, yeah. If there's a unsaturated soil, so you need to refer this one. All right. So this is type of soil material. Yeah. Okay. So you can. This is the reading. All right. So from the reading here, you can know the material lah. Yeah. Okay, the type of soil on your area. Yeah. Okay. Okay, for the advantages, yeah, can detect both lateral and depth, variation in physical relevant parameter, okay, can produce detailed image of structural features present in subsurface. So you can know the features lah, yeah, of your soil, yeah, what type of material that you have for your subsurface. Okay, can be used to delineate stratigraphic ni is the rock layer lah, and the depositional features. Yeah, so sometimes, yeah, in your construction area, yeah, by example, you have a road here kan, example, so there's a road, you construct a road here kan, right? Yeah, sometimes to get the because when they do the construction of the road, they need to get this one, the platform, yeah, to make this platform, yeah. So they will they will do earthwork, yeah. So the earthwork, yeah, some when they do earthwork, sometimes they will cut this area, yeah. Sometimes by example, this area is slope lah, yeah. So they need to cut this area to get the platform kan. So this thing, yeah, this earth, yeah, they will dump the material cutting material here into here, yeah. So that if you do the seismic test, you can know the deposited material lah, yeah. Okay? So that is the meaning of this one, depositional features, yeah. So if you counted, there's a different layer of soil, so meaning that at the top here there's a deposited material lah from somewhere else. So if you want to construct a retaining wall, so you have to remove this one, yeah, the deposited material here, yeah. Normally it's not it's not strong enough lah, the soil, so that's why you have to remove, yeah. So when you do this one, yeah, or you want to do soil nail, so you need to remove the deposited material first, okay, and then construct your nail lah, yeah. So if you construct on the deposited material, normally after some time, raining, yeah, because of the weather, yeah, it will erode it, yeah, the erosion will occur, yeah. So the deposited material here will move lah, yeah, because it's not the original soil here. Okay, I hope this one is clear, right? If you don't understand, just ask, yeah. Disadvantages, yeah. Amount of data collected in a survey can rapidly become overwhelming lah, yeah. So maybe when you knock the apa tu, the hammer on the ground, so the data will become overwhelmed. So the seismometer sometimes they cannot catch up all the data. Yeah, so there is the disadvantage. So some of the data will be missing. Yeah, so they need to a very expert person to read all all the data. Yeah, expensive to acquire, and the logistic of the data acquisition are more intense. Yeah, than other geophysics method. Yeah, so as I mentioned, the equipment is expensive. Yeah, okay, and then the reduction of processing can be time consuming. Yeah, requires sophisticated computer hardware and demand considerable expertise. Yeah, so they need expert, yeah, to read all the data. Yeah, and they need to have sophisticated computer hardware. Yeah, for to interpret the data. Okay, and then direct detection of common contaminant present at direct detection of common contaminant present at level commonly seen in hazardous waste spill in is not. Yeah, so if you do this test, if there's a hazardous material on site, hazardous waste ni on site, you cannot apa the 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 test cannot detect lah. Yeah, so that is the disadvantage of this one. Okay, and then the low density layer underneath. Yeah, a high density layer could interpret the velocity value detected in seismic. Yeah, so that's if there's a hard layer. Um, um, if there's apa tu low density at the bottom. Yeah, underneath the hard layer, hard density, so sometimes the wave cannot pass through macam tu. So that is the they cannot detect lah the lower density soil. Yeah, so that is the disadvantage of using seismic test lah. Alright, okay, so I think I cannot finish this one. Banyak lagi kan? Banyak tak? Tak banyak sangat. So we finish on the resistivity survey. Yeah. So any questions so far? Okay. Okay tak? Berapa slide ni? Banyak slide lagi. So can we proceed resistivity test in our next class? Boleh tak? Because we cannot finish this one in half an hour.
Canada.
So we proceed this one in the next lecture lah, on Wednesday. Boleh? Any question on seismic test? Because if I cannot finish the slide, then we going to have a very short class on Wednesday kan. So I think I better explain that one and in the next class lah, this one, yeah, resistivity survey. Alright, so any question? No, so clear this one, seismic test. Okay, so later on when you are working, so you can introduce this one to your bosses. Sometimes even though this test is well known overseas, but in Malaysia, yeah not the usage of seismic test is not much lah compared to others country. So you can introduce this one lah, when you if you are the designer, so that you can know the soil profile. So you can have you can do your design properly, because you have the soil profile, so no question, so if no further question, so